Hi, I'm Tom Gillis. I'm the general manager for infrastructure and security products here at Cisco. Russ?
Hi, I'm Russ Smoke, and I'm a vice president in the Security and Trust Organization, reporting to our chief security officer, and I look after vulnerability management and offensive security for Cisco.
So, Russ and I have been working together for many years. I build products, he breaks the products. And I must say, he and his team, quite good at it, right? And
Thank you.
we're working together for a common cause, which is to making sure that our customers has infrastructure which is safe, resilient, and trustworthy. And that matters more than ever these days because the whole landscape is being changed by the power of what we call frontier models, which is the new models from the major providers that is really, really taking a step forward with their capabilities. As we got our hands on these next generation frontier models, there's been a shift in what the models are capable of, what we find, and that shift is leading to what I'm going to argue is pretty significant changes in the way that we think about building, testing, deploying, and most importantly for this audience, operating infrastructure at scale. So let's start from the beginning. Yeah, Russ?
So, Tom, I'd absolutely agree. The introduction of frontier models have really changed the cybersecurity game from one of being very operationally focused, very conservative, and in some cases a lot of risk management, and in some cases risk averse, to one where we're going to have to move at machine speed. The days of taking weeks and months to qualify software and take long periods of time to upgrade software are really over.
Yeah,
The adversaries are going to find these vulnerabilities in a matter of days. They're going to find exploits in hours,
yeah,
and it's our job, as defenders, to enable our customers to go out and protect themselves.
yeah. So we're kind of jumping to the punchline here, and I think the punchline for our audience is that I call it the summer of hell. It's gonna be some turbulent times because every piece of software everywhere in the industry, like the thermostat on your wall has software in it. All of these software components have vulnerabilities that will need to be fixed. And so that's going to create a scramble of patching. But when we emerge through this turbulent summer, I believe that we, the industry, can be in a much better place, and that we're going to have truly adopted more of a CI/CD philosophy, that agile, constantly taking lots of little steps to upgrade our infrastructure, which will make the upgrades easier. No more gut wrenching, heart stopping, like, oh my God, I took it offline and now I can't get it to reboot type of upgrades. And we'll be more secure in the process, which is, I think encouraging. But Russ, let's maybe start from the beginning. You and your team have been doing, red teaming and product testing for years now, and we've been using AI tools for a long time. What changed? What's different now?
Sure. So, we certainly have been using AI enablement in the offensive security world for several years. What really changed for us in the last few months were two things, right? There were step function increase in capability and quality for the frontier models,
Yeah,
for sure. So the Mythos models, the OpenAI models that are out there in the world today, absolutely do a better job with cybersecurity. But one of the discoveries that we made as an offensive team is that the driver or the user of the model actually makes as big a difference as the model. So we're able to take all the experience of an offensive security team that has 20 plus years of Cisco knowledge, and now we're able to do that at machine speeds. We're able to get through more products, more coverage, more features, and the agents just don't take vacation and they don't shut down. They run constantly, and this allows us to bring really high fidelity vulnerabilities and areas for architectural improvement in the code that we take to engineering, and for everything we bring our engineering partners, we bring a proof of concept and we bring a recommendation and a patch. So it really has just changed the entire relationship between an offensive team and an engineering team. It's much less adversarial, and there's much less back and forth and much less debate on the findings, which has really allowed us to increase the velocity of fixes. And we have the capability in some cases to actually refactor features
yeah,
if the density of the vulnerabilities are too deep in that particular
yeah.
feature.
Let's pick that up. So I think one of the more interesting developments is anyone in the software industry has been using AI coding tools for more than a year now, right? A couple of years. What I observe looking at our software development teams is that with the previous generation of models, for a new project, something greenfield where we're starting from scratch, we would get a 20x increase in productivity, like just a surge in productivity. You couldn't miss it, right? A small team using these models could create really, really big things. But we struggled to get that same productivity on a complex product which has lots and lots of code. So think about a Cisco Catalyst switch, a Cisco firewall. These are products that have been developed over a decade and that have, many, many million lines of codes. And so in my view, this is one of the big changes is that the new class of models coming from the model providers, these what we call frontier models, are capable of understanding these large, complex products in their entirety. And it's because they can understand them in their entirety, they can look for these kind of unusual, circumstances where I change the state of this process and then it changes the state over here and then it goes to this thing and then it finds this. And so there's these kind of chain of events that would lead to a vulnerability. They're finding vulnerabilities that our best humans that have been looking at this code for a decade have not been able to find, right? So that's a big development. But at the same time, you alluded to this, is super important. Because they understand the model in its entirety, they're able to help us develop new approaches to these complex products and to fix the vulnerabilities, but not just fix the vulnerabilities, to look at the kind of basics of the code and to shrink the code base and to compact it so that we can prevent future vulnerabilities as well. And that's a leap forward, right? We have not been able to do that with the previous generation of models. Do you think that's a fair assessment, Russ?
Well, I think it is a fair assessment. I mean, the context windows, the ability for these models to look at things in context has absolutely improved.
Yeah.
But in some cases, we use open weight models to do some of that work as well, right? So we balance. We have a what we call a harness at Cisco, where we have a group of models that do purpose built activities. So for things that we need, deep inspection and deep context, we'll use a frontier model. But if we're writing a bug report or suggesting a patch or creating documentation, we use other models, right? And we pull all that data together. The other forward step that we were able to make with these models is the frontier models, as we're operating them, we're actually able to go from a static review of our code. So we index software, we look for vulnerabilities, do what is effectively static analysis at high speeds. It does a really good job. The false positive rates are lower than those of the past, but they're still quite high. But then we take that data and we move it into a live testing environment, and that's where the offensive security capabilities at Cisco really start to shine. We put everything we know about the product into a folder. We work through. We talk about all the architectural issues, the threat models, its SDL status, all the vulnerabilities we've ever found in the product, and documentation. And we turn these agents loose to go exploit these boxes using what they have discovered through static analysis and research. And these agents just go through the device piece by piece. If it needs to configure a new protocol, they get configured. If it needs to download a different set of tools to go do some reverse engineering, they will do that. And this orchestrated group of models that we have in this layer we have just taken us to a level where we're doing this at machine speed. The offensive security team at Cisco is less than 100 people, but we're getting the productivity over 500 engineers right now at senior engineering levels. So the productivity has just been astronomical, along with the quality.
Yeah. So I love talking to Russ because he always says things that are interesting. There's a couple of points that I want to pick out from what you said. The first thing we just established is that these new models can understand the complex code base. And what this means for our customers is that we're going to be able to provide fixes and improvements to those complex code bases. The second thing you said, which I think is really interesting, is your observation was that the model by itself is sort of okay from an attacker's point of view. But when you put the model into the hands of a skilled attacker that understands the context of what they're doing, that's where you see the big result. Am I saying that right?
That is absolutely fair. We get another layer or another step function improvement in findings when we add the live testing and the knowledge and the experience of the offensive team. And what it really does is it helps us bring an incredibly high fidelity set of vulnerabilities It allows us to chain them together in attack chains and create proof of concept. So when we turn these over to engineering, there's a deep understanding of what happened, why it happened, and there's actually guidance in our documentation that we give to engineering on how best to fix it. One of the other advantages that we've really taken hold of is the ability to create test cases to go validate the fix. So where it can find a vulnerability, it can create 1,000 test cases in seconds to go exercise our fix and make sure that we don't have additional issues. And we've actually seen testing turn out new vulnerabilities, right? Of even an AI generated vulnerability findings. So we're seeing the agents and the skills they're learning.
Yeah.
And I could even anecdotally say that if we went back and we've done this and scanned a product that we did 3 weeks ago with the same set of harnesses, we're finding new vulnerabilities just based on
Yeah,
the
yeah,
learning.
yeah. Another important point that we got to make here is that sometimes I think customers would like to think, "Oh my gosh, these new tools find every single vulnerability, that is theoretically possible. So once we get through the summer of turbulence, I'll be done. There'll be no more software vulnerabilities." Unfortunately, gang, that's not the case, right? There are new vulnerabilities. There are, as the code changes and matures, there are, new ways to exploit it, and the tools are incredibly good at finding those new ways. And so we as an industry have got to get ourselves in a position that this is an ongoing state, and that the bad guys, the real adversaries, not Russ and his team, but like the real foes here, are going to have the ability to find and exploit these vulnerabilities at a speed that was never possible before. And we, the industry, have to make structural changes about how we manage and update our infrastructure. We simply can't live in a world where we're running, sort of old systems that haven't been updated. And so we've got to bring the CI/CD philosophy, more continuous updates into the infrastructure. What that means as a vendor is that we're going to make it easier to do these upgrades. But as a customer, we need to start thinking about an operating model where we're not hardening our data center infrastructure and updating it once a year, but we're going to be moving to much more frequent updates. Like, is a quarterly update reasonable? Like, where do you see this going?
I think mileage is going to vary, and it's going to be based on product.
Yeah.
It's going to be based on its position and risk factor in the network. Edges and firewalls may have a different cadence than something hardened inside of a data center. So it's going to depend, but the volume is going to increase. And I think even after we finish the summer of turbulence, as you're using it for Mythos, the overall pace of vulnerability disclosure and vulnerability discovery is going to stay at a higher base volume level than the industry has ever seen before. It's going to
Right.
continue. Models are going to get better.
Yeah.
We're going to find new things. And,
Yeah.
I can say, right now in Cisco, for everything that we've worked on so far and everything that we're finding, we haven't discovered a novel, new type of vulnerability. It's more of what we've all experienced in industry. I think we can expect, in more advanced models, maybe to start finding new vulnerabilities or new classes of vulnerabilities
Mm.
that we may not understand. So we need to be in a mode to upgrade and respond quickly, and being flexible and being able to upgrade still doesn't reduce our responsibility to have high availability. The devices should have 5 nines, 7 nines of availability. They should run, but when you choose to take them down, you should be able to take them down, upgrade them, have a resilient infrastructure that allows you to upgrade in stages, because we all understand what availability means. But I think the bias or the culture that just has to change for infrastructure
Yeah.
is we
Yeah.
have a bias of mitigate and work around to save downtime, and that
Yeah.
is going to have to invert to one of upgrade.
Yeah.
It may be very temporary mitigations and then upgrade, but the concept of holding out for months and years before you upgrade are just frankly going to be over.
For decades, people have been operating infrastructure this way, where you kind of resist the upgrade. You're like, oh God, I got to upgrade. And you do the upgrade, Christmas Eve or New Year's Eve or the 4th of July when things are quiet, hopefully. So that's got to change. Almost a year ago, about 8 months ago, we embedded the Tetragon agent into our Nexus operating system, NXOS. And what this allows us to do is, when we discover a vulnerability in our own code, so in our operating system, we can create a compensating control that you can deploy in a switch or router without rebooting that switch or router. And notice I did not use the word patch. This is not a patch. It doesn't obviate the need to patch. It doesn't modify the binaries that are running in any way. So it has very high levels of stability. But what it is it's a pinpoint policy change. And it could be as precise as, if this process tries to access this file, don't allow that. And what we see is we can implement a compensating control with virtually no impact on system resources on the machine. Like the CPU utilization doesn't change. Now, I never say never. Like, we're always very careful to make sure that new controls we issue meet that same test. But the idea here is that you can apply these, we call them vulnerability shields, onto a system while it's running without rebooting the system. And we're building the management mechanisms. You can test one, then you can put two, then you do four, do, kind of a phase rollout. And so the idea here is that if we discover something new in between your maintenance windows, you have the ability to put, this is a finger in the dike, right? And it's an emergency control that you can put on a running system that can provide compensating controls to shield those vulnerabilities. And as I said before, I'm going to say it again, it does not eliminate the need to patch. We still want to go through and patch, and we want to update these systems more frequently than we did. But Russell, from your perspective, is this a big deal? Is this just kind of a, incremental thing, or is this like a meaningful step forward?
I think for embedded systems, it's going to be a really big deal. It's going to allow you to do very short-term mitigations while you're, moving to patch really quickly.
Yeah,
The reality is many of these things are not going to stack up in a unit, right? They're very pinpoint, and they're going to be built for issues that are super critical that we know may or being exploited or potentially going to be exploited. The concept of building tens of thousands of these things for every CV is not what we're after. These are emergency controls,
correct.
but that also ties into the need to stay current
Yep.
in hygiene, right? These are technologies that are not built for products that we put in the market 15 years ago, 10 years ago. So currency and making sure that end of life, end of support things in your network are migrated out, or if they can't be deeply protected in other parts of the network,
Yeah.
because these kinds of technologies are out on the edge, and they're newer technologies, and they rely on all the capabilities that we've built over years with better speed, better scale, and better resiliency in the products. So these are not a silver bullet, but
Yeah.
they are certainly something to help you mitigate and protect.
Yeah, let's be specific about this. So as Russell alluded to, we've been shipping this in the Nexus operating system, which is our data center switch, for many months now. And it is a software upgrade. To be perfectly clear, this is free. This is functionality that's built in to the product. Doesn't require any particular hardware, and we are able to implement this feature on every version of a supported version of a Nexus switch. So that's a really, really good sign. Now, there's another thing you said earlier that I want to circle back to. It was an observation you made that sometimes your team didn't have access to or didn't need access to the source code. That these models in the hands of your red teaming adversaries, these models are capable of finding these vulnerabilities on a running system just by exercising the APIs. Obviously, they're going to be more effective when they have source, but they can just do it to any running system. True?
They will absolutely find exploitable vulnerabilities against live configured systems. We get a step increase when we have access to source code, so we can go deeper. But there is absolutely a capability to find vulnerabilities, and it's going to depend on the operating system, the language it's written in. Your mileage is going to vary.
Yeah.
So yeah, I think web applications will be easier to find vulnerabilities in than deep embedded C or some of the other programs. But
Right.
it is absolutely a capability.
Yeah, which brings us to kind of the next chapter of the story, which is for our customers. All the conversation we've had has been talking about how do we make the infrastructure more resilient, more dynamic, right, more secure. But what about the applications that run on that infrastructure? And I think this is a major, major concern for customers because many customers have hundreds or thousands of applications. Sometimes they're third-party stuff that they don't control, or sometimes they're in-house applications that were written, but the person that wrote that and the architects have long since retired, and someone's got to fix all this stuff. And so, I think one of the things that Cisco's doing that is interesting is we're taking the same philosophies that we have about providing dynamic compensating controls to our own application, which is network operating systems and control planes. And we're making it available for our customers so they can provide compensating controls that can shield vulnerabilities in their own applications, while the app teams go about the job of updating and patching those applications, which, as we know from Log4j, that could take months, right? That is not a small undertaking. And so there's a couple layers of defense that we have here, and this shouldn't be too new to any of our listeners, but it's still pretty important. The first, and Russ, I want you to red team what I'm going to say here, but segmentation is just a good common sense approach. And the more fine-grained your segments, the better you're going to be, because we have to make the assumption that there are vulnerabilities in the code and that the adversaries are going to find them and they're going to compromise the endpoint. It's going to happen. That's the principle of zero trust, but it's more true than ever before. So let's make it difficult for them to move around. Let's put walls in place that can, contain the blast radius. You agree? Segmentation is has always mattered, but boy, let's
Oh,
double down on that.
without question, especially if you need to defend parts of your network that you perhaps can't upgrade or have, devices that have limitations, that, for modern technology. So, protecting your assets based on class and applications, of course, right? And and on top of that, all the things that we all should be doing matter.
Yeah,
Multi-factor authentication, understanding your inventory, software currency, end of life, end of support, moving out of the network or being diminished in the network. All of the things matter. They just matter at a much greater
right.
depth and speed at this point.
Right. So, segmentation has always been something that is part and parcel to a network. Therefore, Cisco, the networking company, has always been really good at segmentation. You can do coarse chunks of segmentation, VLANs, EVPN fabrics, etc. We've taken a step further where we can do segmentation, where we can put a layer 4 stateful firewall, very high performance with hardware acceleration. We bake that right into a switch. So every switch port gets its own little baby firewall, right? And it allows you to create much more fine-grained segments that have true stateful inspection. And we think that's more important than ever before. The way you do this is called a smart switch. So it's a type of switch that can do very, very high performance segmentation at scale. And then the software that goes along with that is what we call Hypershield. Now, building up a layer from that, having the ability to apply compensating controls, even like on a foundational issue like an operating system vulnerability. So the Linux kernel had a bunch of very significant vulnerabilities. With Hypershield, we have the ability to provide compensating controls that can shield those application vulnerabilities as well as the infrastructure, right? And so you can do segmentation and you can shield your vulnerabilities for our customers' applications. And I think that's going to matter a lot because, as you said, the tools don't need source, right? If you've got some custom app that you built in your environment, like the tools are going to keep poking at it, especially if it's web facing, right? The tools are going to keep poking at it until it finds vulnerabilities. And it may take months for the app teams to be able to patch all these things. And so having the ability to put a dynamic control in place that doesn't touch or modify the binary of that app, but can shield that vulnerability, we think that's super important. So it's a multi-layered approach. Segmentation is a foundation. And then the more sophisticated compensating controls for the application, that's going to matter. So in this post-Mythos world, what our customers need to think about is a multi-layer approach to this problem. And some of this is fundamental. Some of this is stuff we've known for a long time, but it's taken on a much greater urgency. The first and most important is that the days of updating your infrastructure once in a while, like every year or 18 months or 2 years, those days are gone. And we need much more frequent updates to all of the infrastructure as well as the applications that are running on it. Okay, that's fundamental. Now, in between those updates, having the ability to apply a dynamic compensating control like we can do with Live Protect or like we can do for applications with Hypershield, that's also a huge step forward. And then having the ability to implement common sense security hygiene like segmentation, limit the blast radius, because as good as we are at trying to shield these vulnerabilities, we know there are going to be vulnerabilities that the attackers are going to find before those shields are in place, and the attackers are going to get in. That's the principle of zero trust. So let's pay a lot of attention to this, put the segmentation in place. And then kind of at the top of the stack, we're putting a lot of energy into building automated AI powered detections that can run in the SOC, that can look for these kind of anomalies and identify when a compromise has happened so that we can then go in and remediate. So multiple layers of defense here, all of which matter and all of which need to be done in a coordinated and thoughtful fashion. Russ, if you could maybe share with us your view of what does a customer need to think about, what is going to change, maybe even like within Cisco IT, like what are we doing differently to manage our own infrastructure?
Sure. So I've got a number of just no regret items that we're advising customers to undertake. And this is gathered from many customer conversations and customer visits I've done over the last few weeks. So this has been refined and tested and challenged. And we have general agreement that these are the right things. So one, segmentation, as we talked about, multi-factor authentication everywhere you can do it, solid inventory and asset management, understand where things are, categorize the risk of that asset, be it an application, a device, or whatever it is, and really challenge your operations team to log in and refine what the software qualification looks like, how to speed that up. Think about using AI tools, the things we've talked about for the last 30 minutes, how I can speed software qualification up, configuration management, all of those hygiene things. And then, more importantly than all of it, is be willing and be open to expand your risk window a bit to take software faster. The adversaries are going to be moving faster than all of us, and we have to go defend this. And it's going to mean some risk, I think, in taking upgrades and taking making changes in the networks. This is nothing that my boss Anthony Greco is not asking Cisco to do.
Right.
We're doing the same thing to ourselves. We are in this with you. We're a large enterprise network. We have many suppliers, so we're on the receiving end as well. And this is exactly what we're doing.
Okay, Russ, we covered a lot of ground here, and the changes that are happening in the industry, these are significant. I've been doing this for a long time, and I've not experienced any kind of change at the pace that we're seeing. And so, as I think about what's the one thing I want to leave our customers walk away thinking about, is that we together need a new operating model for infrastructure, right? And the old model of like harden it, prove it, and then don't touch it, that model doesn't work anymore. And so we're going to move to a new model together. We're going to be working with you, our customers, to take lots of smaller changes. And in between those changes, having the ability to apply a compensating control to the infrastructure while the infrastructure is running, right? Using things like Live Protect to put that finger in the dike to plug those holes as we find those holes. That has to be the new operating model going forward. And I think once we get comfortable with that, we're all going to be better off. Like the upgrades are going to be smoother and easier. You don't have this gut wrenching change, and we'll be much more resilient in the face of an adversary that has remarkable amounts of automation with these tools. Would you agree with that, Russ?
I agree with that wholeheartedly. The only nuance that I would put to that is the summer of turbulence. The upgrades and the changes are going to be more significant. We have to get over the volumetric hump,
Yep.
and then we will move into what I hope and we believe is a more normal cadence.
Yes. I share your pain, and we're going to be here for you all during the summer of turbulence, and make that process as smooth as easy as possible. And thanks to all of our listeners for tuning in. And the one thing I'll tell you is things are changing and changing rapidly. As a market leader at Cisco, we're going to continue to innovate here, and we're going to continue to communicate with you about these changes and what the impact that's going to have on your operations. So stay tuned.